All right, guys, so we're going to solve linear systems, and we're going to do it by 3 ways. So there's only 4 slides in this video. I'm going to show you 2 of the ways on the video, and one we're going to do in class tomorrow. So let's just see what it looks like. We're going to graph them in tomorrow in class, and we're going to use the calculator to do that. It's just easier to show you in class on the calculator instead of trying to put it in the video. It's very difficult to do it that way. So I'll show you that in class tomorrow. I think you'll like that way a lot. Calculator will do all the work for you pretty much, and we'll be all good. Okay, the other 2 ways are very familiar to you. One's called solve by substitution, which we've done before, except now it's nonlinear, which means you're going to have squares in your equation, one of your equations, or sometimes both of your equations. All right, so remember when we do substitution, we're looking for a variable that has 1 as a coefficient. Now, if I'm looking at the second equation, both of them are that case. I'm just going to choose the y and say, okay, y equals negative x plus 4, or you can say 4 minus x, which is the same thing. Now to substitute, what I'm going to do is everywhere I see a y in the first equation, I'm going to substitute 4 minus x. Now just see one y, so it's going to look like x squared plus x minus, I would use the parentheses because that minus sign is going to change your signs in the 4 minus x, that equals negative 1. So I'm just going to work that out a little bit. X squared plus x, the minus sign is going to change the 4 to minus and the x to plus, equals negative 1. Now because it's x squared, you know I have to either factor it or complete the square or do quadratic formula. So I'm moving everything over to the left-hand side. I have 2 x's over here. If I move the negative 1 over, it becomes positive 1, which makes it a minus 3. So the first thing I'm trying to think of is there are other factors of negative 3 that will give you positive 2, and luckily there are. It's a plus 3 and a minus 1 equals 0, which means my x is going to be negative 3 and positive 1. So what I'm going to do is, now that I have my x's, I'm going to plug them back in. This is elimination like we did earlier, back into that where I started. So if I plug negative 3 right here, and I do 4 minus negative 3, sorry, that's 7. So one answer is negative 3, 7. Now I'm going to do the same thing with the 1. If I plug the 1 in up there, 4 minus 1 is 3. So if I get 1 for x, I get 3 for y. And that's solving by substitution. That's all there is to it. Not a humongous deal. A little bit longer than before because you have a quadratic instead of all linear stuff. One more. Okay, the last way we're going to solve, this shouldn't have been a surprise to you. We're going to do elimination. Now, one thing we're not going to do this time is Cramer's rule, because Cramer's rule doesn't work with quadratics. So this is the last method we're going to do. I need to make either the x's or the y's go away. So I'm sitting there looking at it right now, and it's set up perfectly right for those y's to disappear. So I'm just going to add those 2 equations together. The y's are eliminated. It gives me a 3x squared, a minus 3x over here, sorry again, and a negative 2 over here. Again, to solve it, I'm going to move the 2 over, and I'm going to try to factor or complete. It's not a good one to complete the square because I have an odd number in the middle, and I have a number in the front. And 9 times out of 10, if it's like that, if it's odd and have a number in the front, I can't see factors off the top of my head. I'm going to go ahead and do quadratic formula like we're used to doing. So let's go ahead and do that. I'm going to say x equals negative b, which is 3, plus or minus the square root b squared minus 4ac all over 2a, which is 6. So I'm going to get this right here. I'm going to get 3 plus or minus square root of, now that's negative 15 inside and 6 down here. Now because that's an amount, I'm going to get an I right there. And because I'm getting an I, what you're really looking for, and I didn't make a big deal about this, I should have made a bigger deal. When you're solving these, you're really looking for where the 2 graphs intersect each other. That's the solution. So when we get imaginary today, if you get something like this, we're just going to say there's no real solutions. Not going to plug that back in and try to find the y because there's no real solutions. There's nowhere on the graph they would intersect each other because it's imaginary. Okay, so hopefully that makes a little bit of sense. Now, a lot of them we do will have solutions. I just happened to pick one that didn't, which is I'm glad we saw one of those, so you will know ahead of time that is possible. All right, so tomorrow I'm going to solve by graphing on the calculator. Make sure you bring your calculator with you. I'm going to do a little bit of substitution, a little bit of elimination, like we had before, except with quadratics. All right, so can't wait to see you then. And I'll see you.